give you the context again. So if you look at solution to two-body problem. In the practical world, what is this supposed to tell you? What have you been following what we are doing? What is this supposed to tell you, the solution to two-body problem? But what is supposed to tell you, that is the relationship, right? But what is it supposed to tell you on a more day-to-day basis?
Position.
Position of what? Orbiting body, right? It's the position of the orbiting body, or where the orbiting body is, at any given time. That's the limitation is, right now you don't know at any given time, you cannot figure out. You have to somehow relate at any given time what is the true anomaly, and then that true anomaly will tell you what the position is. Okay. So if you're asked what does that solution to two-body give you, you should be very clear on that. You should say position of the orbiting body, or where the orbiting body is. That is what it's supposed to tell you, right? Now, if you look at the solution itself, the solution, as we looked at the solution, it's a function of what? The position is function of what? Right. So R, we write R is equal to a square over mu into 1 over 1 plus e cosine theta, right? Is this visible?
Yes.
Okay. So here you can say R is the in some sense the position of the orbiting body, right? And theta is the true anomaly. Now keep in mind, when the satellite gets launched, do you always know this when the satellite gets launched? What do you know when the satellite gets launched? What do you think you'll know when the satellite gets launched?
Mass. The satellite.
That you'll know even before the satellite is launched.
You know, kind of,
The direction.
The
you know, what kind of orbit you want to send it to?
huh?
You know, what orbit you're sending it into? What kind of orbit you're sending it into?
You have some idea. Yes, you know, you have some idea as to what orbit you're going to send it into. But at the launch time, when the orbiting body is deployed out of the launch vehicle, what exactly do you know? What exactly can you determine? You can determine, we have been talking about this. R and B are known. Okay? Right? What can you figure out from ground? Again, it's the same thing. You'll always know the position and velocity. Right? From ground, you can only determine these.
The angle momentum.
But that is computed. Right? Do you know the angular momentum? What can you measure from the ground? There's a difference between measuring something and computing, right? If you know, can you compute your mass? You measure it, right? Can you compute your weight? Weight is something you compute. Okay. But it's actually the other way. You measure your weight and you extract the mass out of it. Can you measure your mass?
No. Not how.
Why not?
Because of the gravity.
Gravity will be there everywhere, right? Almost everywhere you go, gravity, you cannot avoid gravity, right? So you are going to always measure the weight and then extract or compute mass out of it. So you should know what you can measure and what you can compute. Can you measure the angular velocity? Sorry, angular momentum, h? Can you measure these two? For an aircraft, can you measure these?
Yeah.
Yes, you can measure these. What are the tracking this thing meant for? The radars you see, what are they meant for?
Measuring those.
What does that tracking mean?
Measuring velocity and position.
Yes. So what does that do? How does that work?
Uses GPS satellites.
No?
It's a radar.
What does a radar do?
The change in position of second of an object.
How do the cops measure your position and velocity?
They measure the
They
measure your
measure how far you
They
go.
have the laser guns, right?
Yeah.
That is a radar or a laser this thing which shoots out laser light and then it hits you and comes back. Or LiDAR which hits you and comes back. So it will know the time it takes to go and come back. That is what is measured. And from there you can figure out what is the position and the velocity. Okay. So if you know the position, how is position related to time? What is the velocity being measured there? Or what is the velocity, known velocity?
the speed of light.
Speed of light. Okay. So the speed of light is known. So when you hit and come back, you multiply that by
Time.
the time. You don't know the distance, you know the time. Right? And that is how you compute the distance. Now if you know the two distances, if the cop measures you here and if the cop measures you here, and you know the time, the cop will know what is your velocity. Okay. You do a very similar thing with the satellite as well. When the satellite is launched, you can always measure the position and velocity by just sending a radio wave. And when that radio wave comes back, you know what position, and if you do it twice, you'll know what is the
Velocity.
velocity. Okay. So once you know the position and velocity, how do you extract these? Huh? See, this is if you don't know this, then what is the point of taking exam?
H is R plus B.
Huh?
Wait, if you want to find,
If you know these, how do you extract all this information?
we can
H is
just
R plus B.
r dot r, square root of r dot r, we find the scale of r. And then r across b is h, and then
What is that algorithm? What is it called?
the r dot r, oh, dot r. Step one. The
Orbit determination. We talk about this, right? We have discussed so much about this. So what is orbit determination?
the process where you go through R&D and find the rest of the parts of the part.
Right. So rest of the elements are what? Rest of the elements are
H.
H, A,
I.
E, capital I. So you know, if you know these, you know, you can figure out R, right? Now what is So every time you want to know the position, what do you have to do? Hmm?
Yeah, that's all for all of that to figure out.
Every time you have to measure this,
You have to
figure out this, then do this. You see the process? It's so, every time you have to keep shooting, figure these out, use this algorithm, figure this out, and then figure this out. Okay? So you don't want to keep doing that. What you want to do is, once you have figured it, once you have the initial conditions of R and B, you should be able to just use some function of time to figure out how is the R and B propagating. You understand? That's what we are trying to do here. Now what if we define eccentric anomaly? Okay? And here, what is the expression we derived for eccentric anomaly, between eccentric anomaly and you don't recall that? Root of
1 minus e divided by 1 plus e section.
So this gives you an expression for true anomaly and eccentric anomaly. So Jayla, tell me what were you talking about?
I was trying to go through step by step to figure out how we got from the t squared, the tan squared, we had the from into the sine and then the cosine equation to that.
Okay. Let me finish this and then we'll go back and review that. Is that okay?
Yeah. I was just gonna say that. Exactly.
So now what you know is we define something called mean motion. Okay? N is equal to 2 pi over T. And here N is called mean motion and T is orbital T. So if you have these two, what do you understand by this? Can you develop an understanding? Can you use your, let's say, whatever you have learned until now?
Is that n?
N, yes, small n.
That's mean motion?
Here n is mean motion. Okay. What is 2 pi? What do you mean by 2 pi?
That's one orbit.
One orbit. And what is this?
That's the amount of time you've traveled, right?
Right. So what would this be?
How far you've
When you speak,
Huh?
when you speak,
Orbital is this thing.
Oh man.
when you speak, is this over time?
Huh?
When you speak, or velocity is this over time?
It is velocity. What velocity is it? Huh?
The average.
Velocity is average.
Would it be at that time?
Huh?
At that
What velocity is this? Just substitute the units and figure out for yourself. See. Please keep your cell phone. Please. Huh? Okay. Look at this and tell me what this is. Figure out the units of this. Can you figure out the units?
No.
Why not?
It's just 1 over seconds.
What? What is 2 pi? What is the unit of 2 pi?
Radians.
Yeah, so what is it?
So radian per second.
So what is radians per second?
Omega.
Velocity.
Huh? Omega. What is it?
N is omega.
Angular velocity.
Omega is
N.
angular velocity. This is angular velocity, mean angular velocity. Okay. You understand what mean angular velocity is?
No.
What is the difference between angular velocity and linear velocity?
One is changing direction, the other one is
Right. So angular velocity is measured in radians per second. Okay. Two objects can have the same angular velocity, but different linear velocities. Is that possible? Right. So if they're covering the same angles in the same amount of time, the angular velocity will be the same. Right. How do you convert angular velocity to linear velocity?
With cosine and sine.
Is it angular to linear?
V squared over r. You turn it into x.
How do you convert angle to length?
You don't follow that on 7.3. Sine.
What is the relationship between angles?
Velocity x would be cosine theta, and then velocity in the y direction would be sine theta.
So remember this, r equal to what? What is r theta?
Oh. It's dynamics now.
Huh?
Momentum. The angular momentum.
R theta is sector. Okay? If you have this circle, okay, and you want to measure the distance of this sector, this distance, how do you measure this distance?
That's the arc angle.
Huh?
The arc angle.
That is r theta, r angle.
Wait, is sector arc length or
Huh?
actual angle? Sector is not the length of the arc.
Sector is the length of this. Right? So you understand that now you understand what the angular velocity and linear velocity is. What will r theta give you?
Sector length.
Huh?
The arc length.
Arc length.
Arc length, right? So this is the arc length, right? If you multiply this theta by r, what are you going to get? The arc length. So if you multiply this n by r, what are you going to get?
The linear velocity.
Linear velocity. Okay, you got it? So what we do is we define another term called mean anomaly. Okay, and it's very simple. Simply ME is equal to N into P. Okay. So if I give you what could be the unit of this mean anomaly?
Isn't it really?
It is radians.
Because the seconds cancel.
Right. So if you see this anomaly, what do you understand by anomaly? What is the mathematical term of anomaly? This is the orbital dynamics term, right? What is it?
So in a sense,
All these anomalies, what are they? Angles.
so if n is equal to 2 pi over t,
Hmm.
would it mean anomaly just be 2 pi?
Mean anomaly cannot be 2 pi. Mean anomaly, 2 pi is the complete.
Because the big T is the time that it takes to have like a whole orbit, and small T is just however long.
Small t is just a small section. Okay. This t is 1. So 2 pi would be the complete this thing. So mean anomaly would be whatever that angle you're talking about, right? I'm going to give you this expression ME is equal to
the time period be the same?
Formula for?
For big T, would that be the same as all the other times?
Formula for time period. What is the formula for time period? Recall and tell me what is the formula for time period.
T is equal to 2 pi over square root of u times a to the 3
Right. So time period is proportional to the mean distance, right? So that is the formula for time period. Okay. Time period. How do you figure out the time period? If you are given the exercise of figuring out the time period of, let's say, if you are given the task of figuring out the time period, how would you do that? I will ask you, go out in the field and figure out the time period of an orbiting body.
If I have a, if I can find the
If you know the position, if you know when it is going to appear, you're going to sit there and see when it reappears. Right? And that is the time period of for completing one orbit. The moment it reappears there,
really just gonna sit there and monitor it.
sit there and monitor it. Once it passes again, then you figure out the time. And then you, based on that time period, you kind of estimate that it's going to reappear around this time. And if it reappears, then you have calculated the time period correctly. From that, what can you estimate? The mean distance. So I'm going to give you this expression.
I got a new question now, because when we were looking at GNet,
Hmm?
their orbits didn't, their complete orbit didn't start and stop in the same place because of the rotation of the Earth. So would it,
Right.
does the rotation, the fact that it's moving, not, how do I,
Yes, you have to account for the rotation of the Earth. But you know the rotation of the Earth, right?
so
you
would
can-
you take that orbit and subtract how far we moved?
Right. So you can take this. Now this gives you an expression for the mean anomaly. I can derive this for you, but for now, take this expression. Okay. What is this quantity?
How did you,
Just take this expression. For now, don't worry about this expression. I'll derive this for you at a later time. Yes, Neil.
I was gonna ask if that expression in the middle is supposed to equal like E from the.
Yes. So here, if you see what is this, what did we derive this as?
That's from the.
Yeah, if you look back at what we derived at,
What you
This
gave
is-
to me.
how does NT relate to? That's what I'm. If your equation for mean anomaly is NT, then
yeah, this one is not from this. This is an expression we derived. I can derive this at a later time. Okay. I'm just trying to get you guys to this is E. Now tell me if you understand this. If this is E. Look at this and look at this. Okay. So this E over 2 or tangent E over 2 is what? Tangent inverse is root of 1 minus E, 1 plus E tan theta over 2. Right? And you just, that is E over 2. There is 2 here. E over 2 into 2 cancels over.
And that equals to E, or is that minus?
That is minus. So this is minus. This, what is this?
What's that second time?
So look at that, what is that? Just focus on this. Okay. We have expressed this as sine E. Look at the expression for sine E from your class notes. Sine of E is 1 minus E square sine theta over 1 plus E cosine. So if I look at this ME can be written as E minus E sine theta. And what is this ME? ME is simply N T equal to E minus E sine theta. This expression and tangent E over 2 minus equal to these two together should answer that question about how you can figure out this R as a function of time. What is this T?
It's time, it's a certain period of the
Right. So can I write this T here T as, let's say, it's the time instance. This is a time instance. Okay? Or it's, let's say, time after periapsis passage. So if you say the time at periapsis passage is 0, okay? So think about this. This is your orbit. I'll complete with this. How did we define true anomalies?
It's the angle of, it's the position, it's
So
the
this is
angle
a position,
between
right? This is
the object and
this is a true anomaly, right?
So from the periapsis to that point is R data.
Right. Here, what happens is that is true only for circle. Okay, so here you have to take the mean distance to figure out. You have to take this distance and this distance is different, right? So you have to figure out that. Now, let's focus on this. What is this? The center.
the center.
And that is the reason we convert everything to a circle. Okay. Now, what is this T?
time it takes to get to.
It's the time it takes from here to here. You get it? So now if you keep a track of what, if you just, it's like, you put on your stopwatch here, okay? You start your stopwatch here and it keeps going. If you know what time it is, you can figure out what the eccentric anomaly is. You see? Once you know the eccentric anomaly, you can figure out what the true anomaly is. Once you know the true anomaly, you can figure out the position. You understand? What is the purpose of this?
To find the position.
To find the position as a
Function of time.
function of time. So you don't have to, if you do this only once in a while, if you just, you cannot keep shooting a radar into space all the time. Somebody is going to do that for you and give you the position at a certain time. Okay, position and velocity. Now you need to keep propagating. How do you propagate? If you want to propagate the position, what do you need to propagate? Let's say I call you up, okay, and I tell you this is the speed I'm going, this is the direction I'm going. If you want to estimate my position after a certain amount of time, what do you need to know?
Velocity.
Yes, I've told you the velocity, I've told you the position at that time. You need to keep a track of time itself. Then you'll know after a certain amount of time where I am. Right? Now think about if I have to tell you, every time you want to know my position, I have to call you up. That was what was happening here. Okay, this solves that problem of trying to call up every time. If you keep a track of time itself, you know where the operating code is. You see it? But you need to know initially, at least initial conditions you need to know. After that, you just keep a track of time. And you can figure out where the operating code is. Alright? Any questions so far? Everybody good?